So thank you all for joining the DevOps section, breakout session of Dataverse 2021. Those of you who attended the DevOps session of Dataverse 2020 may recognize my slides, and for that reason, I'm using fewer of them. But as part of the introduction into this section, I was going to give a sort of high-level overview of older and less old technologies which are in use to install Dataverse. This session is primarily about Dataverse in the cloud, however, and running Dataverse in the cloud is a personal dream for me because a serverless architecture means I can stop spending so much of my career worrying about servers. The slides will be available after the talk. I think we're uploading them centrally. If not, these are a PDF and I'm happy to share them with anyone who likes. But again, if you saw this bit of the introduction last year, this is more or less a chronological list of technologies which can be used to install Dataverse, not in the cloud or in the cloud, ordered by the first commit, the Vagrant first commit being April of 2014. Some of these technologies may or may not be kept current. They're all open source. They're all on GitHub. And I imagine that each of these installation technologies would welcome contributions by interested parties, especially if they don't have a current active maintainer. So if you see something you like, you can look in the slides over here on the left. These are my slides from last year with links to each GitHub repository. But again, this breakout session is really about Dataverse in the cloud. So this is an intentionally short introduction to give Slava and Stefan lots of room for presentation and discussion about where the Dataverse project is going. And if anyone has any questions, should we save them for the end, or do you want to do questions all along?
Yeah, I think in the end.
Okay. Who's next? Stefan?
No, I will take over. 1 second. I will try to share my screen. Yes, now I can do that. Okay, can you see my slides?
Yes.
Yeah, okay, great. So my name is Slava Tikhanov, and I'm lead software engineer in Shock project, and I'm also part of Dan's research and development group. And I'm going to tell you something about Dataverse deployment in the European Open Science Cloud and about automated continuous integration and deployment testing, installation and deployment. So this is what we will get in this session. So it's about European projects and about Shock and about the Eos Synergy, and SESDA maturity model will be presented. You'll know something about Docker, Kubernetes, and serverless deployments and community-driven quality assurance plan, and about automation with pyDataverse. So it will be presented by Stefan. And quality assurance as a service developed in Eos Synergy project will be presented by Samuel. Okay, so let's start. So yeah, a few years ago when we started to work on Shock project, we already had this nice presentation what we want to achieve. But just to remind you, Shock means Social Sciences and Humanities Open Cloud, and we have 47 partners in this project, and it's a big European project and a lot of partners involved, and the idea that we want to build data infrastructure that can be reused everywhere, and it should follow common standards, and it should be interconnected to existing and new infrastructures in the cloud. And another project that will be presented today is called Eos Synergy, and it's also a collaboration of, I believe, 12 partners from Europe, and it's led by Spanish National Research Council. And this project is about software quality and software quality as a service framework that they're developing for Synergy partners and for all partners in the European Open Science Cloud. And this part, I already mentioned, it will be presented by Samuel. So just before I will start, I'm going to tell you something about our vision. And I'm from Dance, I'm from Netherlands, and we have this nice picture how we see future data services in our organization. And basically you see from right side, Shock and Eos Synergy, and we're going to develop a cloud infrastructure in Shock project and increase maturity in Eos Synergy. And from left side, we also have Claria project, which is about linked data and semantic web. So basically we want to reuse functionality and also to get all stuff from Dataverse connected to semantic web and linked data. And it should be available for all researchers and in a really linked and sustainable way. So first, I'm going to tell you about interoperability in the European Open Science Cloud. So we basically have 4 major topics. First is about technical interoperability, and it's about the ability of different information technology systems and applications to communicate and exchange data. This is where we're working on software quality assurance and other pipelines that will allow to automate things, and basically people will be able to reuse all software, even created in different countries and different organizations. And second is semantic interoperability, which is ability of computer systems to transmit data with an ambiguous and shared meaning. And for this work, we are working on external control vocabulary support, and we are trying to add semantic interoperability in this work and to make a sustainable linked data infrastructure that will allow also knowledge discovery and standardized data exchange. Of course, organizational interoperability, which means that we are working together with communities. We are collecting all feedback from all users, and we are basically trying to do it to do all developments in user-focused way. And legal interoperability is about laws, policies, and other regulations. Well, I think everybody of you heard about GDPR law, which is quite big here. It has big impact here in Europe, and it should be covered by all these legal interoperability issues. So our first task is about, in Shock, it's about hosting and sharing data repositories, and the idea that we will develop a common infrastructure for all EOS partners, not only for Shock or not only for Eos Synergy, but all people participating in European Open Science Cloud should be able to reuse this functionality and deploy own instance. And for institutions that don't have this possibility, they can also use services that big communities like CESDA will provide for them. And we should deliver this after 38 months. And I should admit it's quite soon. So we have 8 months to go and the project will be finished. And after 40 months, basically, we're supposed to deliver a report on principles of governance and sustainability of the data repository services. So services in the European Open Science Cloud should follow CESDA maturity model. This is how it's called, and it has a lot of levels, and it also requires at least level 8 of maturity. And from right side, you can see what it's about. It's about system test, launch, and operation, and system subsystem development. And it's a little bit higher than just technology and demonstration that you have in most of research projects. So we need the highest quality of software to be accepted as a service, and we need also clear evaluation of services and evidence of technical maturity. And of course, we have to stop services that will go out of the warranty. So says the maturity model is really aligned with software quality assurance as a service framework. And this is something we are going to tell you during this workshop. So now I'm coming to Dataverse deployment on CESDA Cloud. So basically we're using Docker Compose for local development and also testing Kubernetes. And currently we are trying to merge 2 different repositories. So basically Docker module and Kubernetes module will be merged, and it will become common module, and you will get a possibility to use different deployments for different use cases and for even different clouds. But the idea for SESDA that we will use continuous integration and deployment pipeline in production, and with Jenkins and Helm, we are now working on Helm deployment, and basically all of this will be available for all people from Eos community and also for people from outside. So you can just get our stuff installed in your place, and we can also provide some maintenance and support for this. Okay, so I will go to my next slide. Yeah, so first is about the Docker module, and we created this module quite some time ago. In 2018, we got SESDA project, and we tried to run Dataverse on Docker. And basically now we are maintaining this module, and it's updated to latest version 5.5. And you can use it just for demonstration purposes if you want to quickly to deploy Dataverse and to show to your researchers or to your colleagues what Dataverse can do for you. And using a nice and beautiful Python module from Stefan, you can populate with some sample data sets, and you can basically imitate running instance. So it's quite useful for you because you can do it with simple command line with deployment. Well, of course, everybody heard about Docker, and there are a lot of advantages. I will just mention that deployments could be done, of course, with Kubernetes, with Docker Swarm, and there are a lot of orchestrator tools available. And for us, it means that after we use Docker, we will get faster development and deployments because everything is reusable and open. And again, because Docker allows to scale up apps in the cloud. So this is perfect opportunity if you want to deploy and run data infrastructure with a lot of data sets. So you can scale it up and you can adjust your resources. And also you can archive your Docker images and basically run containers after everything is archived after some time. So Dataverse Kubernetes module was created by Oliver Bertuch, and he's from FZ Jülich from Germany, and it's available in Global Dataverse Community Consortium now, and it has support for Google Cloud, Amazon, and Azure. And yeah, I already mentioned that we're also trying to contribute to this module, and we want to maintain and support it after our project will be finished. So how to deploy Dataverse on the cloud, Google Cloud Platform? What you need is basically running virtual machines, which is available in Kubernetes cluster, and Docker images that are maintained by IQSS. And also we have Docker images from Eos Synergy. And there are some deployments and services, and load balancer and mail relay. And basically, last thing, you need persistent volume, and you can already deploy Dataverse on Kubernetes, the Google Cloud Kubernetes. And another thing that you need just JCloud, which is command line tool for running commands against Google Cloud Platform, and kubectl. And I will show you in further slides about kind of new way with Microsoft Visual Code Studio. It can get things much more simpler than just to use command tools. So this is cloud architecture of Dataverse, and so basically when we started to work on SESDA Dataverse, it was the first thing they did. We make a split of components. And now Dataverse has Dataverse image and Solar and Postgres images. So basically everything is deployed in Kubernetes cluster, and it could be scalable. You can also scale it both horizontally and vertically. For example, if you want to add more nodes, if your Dataverse is becoming too slow, you can do that in this Kubernetes. And you can basically use load balancer to reschedule your traffic to other nodes, which is very convenient and efficient. Okay, so of course, if you need to deploy a Kubernetes infrastructure, you need to think about persistent volume first, because otherwise all stuff that you have in the running Docker container, after restart, it will be lost. So that's something must have to consider which paths will be persistent. And also, I really advise you to consider S3 as a storage layer, because if you will store data on persistent volume of Google Cloud or Azure, or I don't know, Amazon AWS, it could be also very expensive, because you have not really efficient way to store data, and you will be charged a lot. So S3 seems to be a more appropriate way to do it. So now I'm coming to software quality assurance process, because we have Kubernetes infrastructure for Dataverse, and we have all stuff. So how to get all updates of Dataverse automatically tested? So we started to use Selenium Ide, which is a very powerful tool, and it allows to create and replay user interface tests in your browser. So basically, you can create your own test, and you can contribute to Dataverse community, and after it could be shared with and reused by other people. So they can basically replay your own test, and they can also create their own tests if they would like to contribute back. So we have a hope that after people will start to use this approach and more tests will be created and shared, it will certainly increase the maturity of Dataverse and all tools. And it can bring a really good feeling that everything is maintainable and sustainable in the end, because this is a nice way how the community can work together and help together and basically increase this maturity. So you can see GitHub a link from the Global Dataverse Community. There is a repository where we already published some tests that available for sample data sets published on Dataverse GitHub. So next slide is about continuous integration and deployment. So Samuel is going to tell you how it works in very detail. However, I will just say, I can say a few words. After something is getting updated, we have Jenkins pipeline, and it's receiving notifications, and it's also a closed workspace, and run SQL tests, and does different kind of checks. So also very interesting fairness check, and that's something for Samuel also. So basically, we are able to automate things. We are able also to test fairness of data sets deposited in Dataverse. And we can also automatically issue digital badges to show the maturity of software. And basically, after everyone will pass all tests, we are just creating Docker images that getting published in some registry. And after all Kubernetes deployments will be automatically updated. So this is our approach, how we want to continue in Europe with European Open Science Cloud, how we see all services are getting built. So now I'm coming to applications. So I already told you that our preferred way to run this continuous integration deployment pipeline for Dataverse, but also for all tools that we have. For example, data previewers, because they're just written in JavaScript, they could be placed in one Docker image and also tested with the same process. So no problem. Same for external control vocabulary support, for linked data compliance, for multilingual support, and it should be just reusable for any kind of applications and services that are getting integrated with Dataverse. And even more interesting, in some cases we have, and we are using services that and tools that created by others. So for example, WebLate, latest version we are using out of the box. And what we do, we also have established WebLate as a service on Shock website by SESDA. And we are able to rebuild it automatically and also pushing in on repository and deploy on Kubernetes. So not a problem that it's maintained by other people. It's just getting tested in our environment and getting redeployed, and all updates should be done smoothly through the process. And oh, I don't know why it's stuck. Okay. Yeah, so another interesting application that I wanted to show you, and also hopefully it will be integrated in Dataverse in a more sustainable way. So we are working on a so-called Clarion switchboard, and Clarion is linguistic community. And they're working on a lot of tools that could be used to get some natural language processing processes, workflows from Dataverse, and also you can switch and you can select what you want to do, what kind of processing you want to do with data that you already have in Dataverse. So basically, this switchboard also can be integrated with continuous integration and deployment pipeline, and to make all processes sustainable and contribute to the maturity of Clarion itself. Okay, so I already told you about Docker, Kubernetes, and what's next. And next is called Serverless, and basically it's kind of, well, it's here for some time, but now it's getting really, it's emerging in the world, and probably more than 30% of services already deployed as serverless. So what serverless means? Can you consider basically, in some cases, that you don't need server to provide your services? You can rely on a manageable service that provided by cloud itself. And serverless framework basically allows to upload your code to the cloud space, and it will automatically provision and run it without any extra efforts. So you don't have to think about any deployments, about YAMLs. It's basically done automatically. And even more nice that it's basically a stateless approach. That means that after you will get something deployed, it will not cost you money, because it will be just stored somewhere on some storage layer like S3, and it will run only on demand after you will send requests to this service. And it means that if you don't have too much requests, it will be almost free for you. And I believe for AWS Lambda, it's like 1 million requests for free, and after you should pay probably $40 per month, something like that. So yeah, this serverless has already support by major cloud services like AWS, Lambda, Azure Functions, and Google Cloud Functions. And like I already said, it's the cheapest way to deploy something at the moment. Okay, so yeah, just remember that in active serverless application, because it's in stateless mode, it will require some additional time to respond to requests. It means that if you want to deploy Dataverse as serverless, probably it will be very slow, because it has to be go up and down. So it's not really efficient way. However, for some services, for some data previewers, for example, it's like perfect solution, because you're just going to some data previewer, to spreadsheet viewer, and it will just automatically up, and it will get data, and after it will do some stuff, and it will go down. So just very efficient, and it will be less expensive than if you will have a separate container with all stuff running. Also, you can deploy data computing tools as serverless. For example, natural language processing. These all models could be deployed back in this way, and also it's quite efficient, because you're not paying extra expenses for running virtual machines. Okay, so just to show you example, we are working on external control vocabulary support, and basically we want some service to archive all concepts that people deposit in Dataverse. It should be done automatically, and it should be done on demand after people will change something in their metadata and will put some term URI. And we implemented first application for demonstration purposes. We're using a Lambda function, and we also deployed on Harvard AWS. And this application actually does archiving of concepts from control vocabularies. So you can also see it from GitHub if you're interested. Okay, I already mentioned Microsoft Visual Studio Code once, and this is really cool editor. And it's basically integrated. It has integrated CLI, and it has a lot of functionality Basically, it allows to do cloud-powered development, and you can use it for any kind of activities because it has very nice plugins that you can just reuse for different purposes. So I really advise you to take a look if you want to do something with the cloud deployments. Okay, just to summarize this talk, so for maturity of Dataverse core and apps, we are following the maturity model, so you can find it on Zenoda. And all our goal is to automate all tests, workflows, integrations, and follow software quality as a service framework and score as high as possible according to the SESDA maturity model. So our next speakers are going to tell you more details about that. So it will be Stefan Kasperger, who is DevOps and Python developer at SESDA, and he's also creator of pyDataverse module. And Samuel Bernardo from LIP from Portugal, he's going to tell you about Eos Synergy and about software quality as a service development. Okay, so now I will stop, and Stefan. Yeah. How to stop this? That's strange. Danik, can you disconnect me?
Sure, I can try. I can stop your video.
Oh yeah, I see button now.
Okay, there we go.
Okay, thanks. Probably, I don't know if people have some questions. I see. No questions until this point.
Great, and if people do have questions, please feel free to add them to the chat, and I'll make record of them in the notes document. And then at the end, we can have the presenters respond to the questions. Go ahead, Stefan.
Okay, can you see my slides already?
Yes.
Do you see my slides? Yeah, okay, yeah. Okay, I want to show you a little bit about the world of automation in Dataverse and how pyDataverse helps with this. So you can find all the materials on the GitHub repository. Here's the short URL. So you can follow through, but especially afterwards, you can reproduce stuff yourself. And before we can have a look on what automation and migration is in the Dataverse world, you need to understand a bit about pyDataverse itself. And pyDataverse essentially is an open source Python module for Dataverse, and it should help you with Dataverse's metadata and data formats, and also with its different APIs. And the original purpose of the project was to do some data migration activities at Oster. And last year, I moved on to support some automation issues, especially through testing. But there are also microservices running with it in the presentation. It's on pip, it's open source, of course, it's tested and it's documented, and you can find it on the GDCC GitHub organization page. It's now an official GDCC project, and it's funded by Oster and by the Shock project. And I think the best way how to show what pyDataverse is always to show a small demo. So I have to switch over to the video. One sec. Yeah. So in this small demo, you will see how you can import metadata, a data set, and its metadata into pyDataverse, into Python, basically, and then upload the data set via the native API into your Dataverse installation. So first, of course, you always need to import the necessary modules. We need the native API, the data set, and then you define the file name of dataset metadata, the JSON file where all your information is in. Then you create the dataset object, import it with the from JSON function, and then you see the typical JSON output, which is necessary to do an upload via a native API. So this is all in Python now, and you can manipulate it and everything. So then if you want to upload it, you need to create an API instance where you have to pass the base URL. It is running on a local Docker installation in the demo and with the API token. And then you can use the create dataset function. And first you have to pass the Dataverse where the dataset is attached to. And then you need to pass the JSON, the metadata as a JSON string, which in our case is created by the dataset object defined earlier. And as you see now, you have a dataset created with a PID. And now you can also get the PID and use it to publish the existing data set. So now you published it, you pass the PID and define the release type, and then you see you got a published data set. So let's go back to this. So can you see the Jupyter Notebook slide now?
Nothing yet.
Yeah, normally it should work. It's sometimes a bit tricky with the presentation mode. So there's another use case where you can use it for data science for your students or your researchers. So a very common use case is you want to have a specific data set, a data file on your Dataverse instance. Sorry.
Oop. Did we just lose him? Oh, he's back.
So sorry, where did I get lost?
You were just starting to talk through the Jupyter Notebook use case for data science.
Okay, yeah, then that's fine. So let's start there again. So okay, yeah, that's the use case for researchers and for students, and you often want to import a specific file, a spreadsheet, data table into pandas to work with the data frames, and see you get the data set. Once you have the data set, you can iterate over all the data files included in the data set because you need the file name and the data file ID for one. And once you have the data file ID, you can then get the data file and convert it into a pandas data frame, and then with a few lines of code, you can do all the pandas magic and matplotlib stuff, whatever you want to do. And I want to emphasize also to have a look on the documentation. A lot of use cases are in there. I did a lot of work on that, a lot of user guides. So here you should find everything to get started with using pyDataverse. So, and another very important use case and the original idea why pyDataverse was created was migrations, data migrations. And so far I've done 4 different data migration projects with pyDataverse. The first one is from a Dataverse instance to another Dataverse instance. And the other 3 ones are from a Nestor project to Dataverse, from a GSSD space data structure to Dataverse, and also from paper. We collected information from original paper studies and imported it then into Dataverse. And it's always done in this case via the CSV template. So the original format was converted into the CSV template format, and the format, the CSV files were then used to create the data on your Dataverse installation. And so far, only at Oster, I've used it to import more than 1,100 data sets and 1,900 data files. And I would say it saved so far about 600 hours of, mostly boring work, I would say, like copy pasting from your spreadsheet to the front end on Dataverse, and this is done automatically. And the scenario and the use case I've been working most on the last half a year is the Dataverse test project, which is basing upon pyDataverse and also on PyTest and Selenium. So there are also some front-end tests in it. And the core idea for this was
okay, so I think we may have lost our presenter again. Stephanie,
sorry, I don't know, never had this issue.
No worries. Can you turn your video off? We're getting a bit of delay on the audio, and that might help.
Yeah.
Great, thanks.
Okay, where did I get lost? What was the last slide? And
Stefan, you were just starting to talk about the QA test automation stuff.
Okay. Yeah, sorry. Okay, let's give it another, which should help to automatize DevOps activities. And it should not help you. It's not doing some unit tests on backend tests of your database. It's mostly front end, and it's about helping you with legal stuff and basic functionalities like login. It's open source. It's also on GCC, and it's quite new. So I'm very happy if anyone uses it, and it's also funded by Oster and by Shock so far. I think that there is an API, an OAI, PMH, endpoint, sitemap, robots, and also the terms of use apply as you want. It's legally quite important. You also have some front-end tests where you can create Dataverse on the front end and do some search. And two of the most important functions, I think, is that you can test authentication with different users, and also if the data is complete. So if, for example, you do an upgrade and you want to verify that the data before the upgrade is still there, there are some tests for stuff like that. And to show you a basic test, I want to give you also a short demo. So here you can see the test written in PyTest. Here you can pass parameterization, the different users you want the test to be run with. And then you have to create your own configuration file for this test, where you define which users the login should be tested with and what the expected output should be. So then you have to execute the test in your terminal. And first you have to define an environment file where all the basic installation specific information in a .env file is stored. Then you have to export the browser engine to the path. So the browser is located, and then here we define headless so we can see the browser in the test actually running through it. And then you already can start with running the test. And for this, you have to use PyTest. And the driver, the browser, which is Firefox, and then you have to call the test file itself. And now the browser pops up, goes to the root page, closes the cookie rollbar we have at Auster, go to the login page, select the institution of your Shibboleth provider, and then you have the specific Shibboleth login. And that was a little bit too fast. Here you see now on the top right corner that the user Susi Fröhlich is logged in. This gets asserted, and then you can verify that the test was running properly, which is then passed at the end, and that's it for the Shibboleth front-end testing. So it should be easy to be used for others too. So let's go back to the slides again. So in addition to the tests themselves, there are some helper functionalities, and especially important is the create test data function. But you also can remove the create the test data. You can collect all the whole data of the whole instance. And you also can create users with the helper functions. And the create test data is a functionality where you define in a JSON file a sequence of data to be created, and you can create the tree structure from whatever data you have and whatever metadata you have. And just by calling one function, you can create the whole test data setup. This is very handy, and yeah, for this, you also always need test data, and there is also the Dataverse test data repository, which is a collection of quality metadata. It's only metadata, not files itself. But for files, I can recommend having a look at the IQSS project Dataverse sample data. So this is used for a lot of testing purposes we do at Auster. And for the closing of my part, I want to put an emphasis on the open source way of doing things. And I always think open source projects are as good as the community is. And I especially want to tell and to emphasize that the projects I've started and showed you in the last 15 minutes. They are not mine. They were transferred to the GDCC organization, and they are community projects. And as it's usual, they only can sustain if others join in. And I'm very open for any kind of contribution. Just use them, create some issues if you find some problems, and especially important, of course, contribute to it and extend it with additional tests, with making things better and easier to use. So that's the ways how you can get in touch with me. That's so far everything for me, and I think the Q&A will be then after the end.
Okay, thanks, Stefan. And I don't see if there are some questions. Probably no questions at this point of time. Okay, Samuel, are you ready?
Yes, let me share my screen.
Okay.
So I hope you are seeing my screen now.
Yes.
Okay, thanks. So as Slava presented me, so I'm here presenting the Eos Synergy project and the Sql platform that tries to link all the requirements for the testing tools and also the FAIR principles and integration with services and software development. So in this presentation, I will not focus on the demos. I hope that you can enjoy our work and follow us later and see our demos and follow our workshops about all these topics. Here, I will only show you a brief and summary presentation over our project and our work on the SQL as a service platform. So Eos Synergy project is a European funded project that pilots the information and communication technologies required by scientific use cases mentioned here as thematic services. In practice, we are implementing the European Open Science Cloud and providing the thematic services, the SQL as a service platform, that I will explain later. The project has an European community grant of above 5 million euros to support the development. Until October 2022, 17 research institutions in partnerships and 107 technical and scientific staff involved. We have the Eos Synergy site, YouTube and Twitter channels where you can follow us that I placed here in this slide. So looking to the thematic services, they cover several scientific scopes, and I will briefly present them. Here we have the Earth observation thematic services, like WARSICA, that can be used for coastline detection, inland water bodies detection, and water leaks detection on irrigation networks. SAPS, that looks for the water management and analysis of the evolution of forest masses and crops. And GCORE, that is used by European Space Agency and also national programs to provide a data manager for spatial and non-spatial purposes. We also have another thematic service on the biomedicine and astrophysics, CPION, to deploy a data processing cluster in the cloud for structural biology use cases. OpenEvents, used to evaluate bioinformatics tools for Elixir, that is an intergovernmental organization to join together life science resources across Europe. And LAGO, that is the Latin American Giant Cosmic Ray Observatory. Also looking to the environment, we have UMSA and targeted mass spectrometry analysis, looking over the impact of environment in human health, water supply systems modeling and analysis, WSS, that allow operators and researchers to analyze the toxics in drinking water supply networks. O3AS, that cares about the ozone analysis and provides trends from climate predictions. And SDS was aiming to learn about possible dust events related to the mineral dust forecasts. We are also piloting the expansion of Eos to Latin America, in particular in the area of agriculture and the environment in Brazil, and in astroparticle physics through the LEGO Observatory. This is a unique activity in the Eos ecosystem of projects that we hope will have future exploitation opportunities in current and future projects. So now looking to our work. So with Eos Synergy, we pretend to deliver a platform that brings better quality to software and data, fostering the adoption by the community. This project provides a portal where thematic services can connect to software best practices and to the adoption of fair data principles. In the end, all process will be automated by a pipeline that I will explain in next slides. So, okay, so we have automatic services interested to use European cloud, and they have their services being available for the scientific community. But we have here a big challenge. So how can we provide those services into the available cloud providers? And from the software source code to the Eos marketplace, where the service will be published, there are several challenges and concerns that requires interaction between all working teams. And to simplify all processes, here is represented the pipeline that shows the joint work that are implementing to turn all process most automated and simple as possible. Those challenges and concerns are translated into a pipeline that implements and validates software, services, and data criteria. In the end, will be delivered quality badges that certify the achievement of a validation goal composed by a subset of defined criteria. Here, we are also applying DevOps practices to achieve continuous integration and delivery for the services and fair principles adoption using open source software. Now, looking here, this is where I connect my presentation with Slava presentation. So as I explained on previous slide, that pipeline can be implemented like this. So it can be translated into a code. So for that, we are using Jenkins open source automation server that provides the solution to build, test, and deploy the required software. The implemented workflow is described in this slide, like already Slava explained before, where developer pushes code to GitHub platform, then Jenkins starts running the pipeline, deploying the services, and applying the required tests. It also runs the test tools for fair metrics check, automated by the SQL as a service platform that I will give more details later in this presentation. We are now finishing the platform development to support Kubernetes deployment that is expected to be ready next month. So looking to the part of the criteria I mentioned before. Currently, we have defined the quality criteria available in two documents, the software baseline and the service baseline. Current versions are available with DOI references for any citation. Any issues, pull requests, or comments are also welcome in GitHub repositories mentioned in this slide. So the idea here is to represent all the challenges and all the details that we need for the software, for the services, and also for the data in these criteria that we can then translate to code and apply it in the pipeline to produce quality of service, of software and service and data. So now let's look to the SQL platform and see how it can just automate all of these. So just look into a quick overview of the platform. It comprehends the web portal for users interaction and the REST API for the extended adoption, implementing the open API specification for SQL as a service. The core components are Jenkins and JEPL, formerly the Jenkins pipeline library, that is being actively developed by this project. JEPL dynamically generates the Jenkins pipeline from configuration files, applying all the required criteria tests over the deployed software, services, and data. JEPL supports any Git platform, as I mentioned here in this slide, GitLab and GitHub. In the end, we need the awarding system to conclude the assessment. Badger is the adopted batch issuing system that implements the Open Badges specification. So summarizing the main actors of this platform, what we have JEPL that automates the deployment over Docker Compose or Kubernetes with Jenkins pipeline code from provided YAML configuration files. We also have the SQL as a service portal that is the most simple approach for first interaction with the platform, where users are guided over web forms to generate the required configuration files for JEPL. And Badjar is your profile targeted primarily to software and services badges, but also be used for fair awarding. I want to give another important detail here about the JEPL library. JEPL is a shared Jenkins library that can be used in any Jenkins instance without administrator privileges. It is directly imported from Git repository for the desired release. We are open to any contributions or feature requirements over GitHub pull requests, issues, or even project cards. So this is now in more or less the middle of the project, and all your contributions or suggestions and feature requests are welcome. So looking to an example of a minimal example of what we are doing. So here is an example of a dynamically generated pipeline by SQL as a service that is produced from, so the SQL portal connects to the API server that generates the required configuration files for JEPL and Jenkins. In the end, it produces the pipeline delivering the report with the test results. In the left, in this slide above, you have an example of a configuration for the pipeline, and down the Jenkins file that uses the JEPL library. So using the JEPL configuration, the pipeline on the right is dynamically generated, where stages are produced to deploy the required services, the criteria tested, and the Docker image is pushed if required in the end. Now looking to the portal. So the SQL portal provides simple web views with instructions for the users to meet their software repositories. It also simplifies all the complexity behind the pipeline, fostering the adoption of better software and data. Here, users find the simplified first experience, not requiring any further knowledge of API, JEPL, or Jenkins. This also provides a faster adoption approach, where users can start to collect the feedback as soon as possible. So looking to the part of fair assessment, with ORCIC Automatic Service, here as an example, we have implemented the pipeline to check fair data over Dataverse repository. The ORCIC Dataverse receives all generated datasets from the processing jobs that are mapped with the expected metadata. Fuji and Fair Evaluator tools allows to check fair metrics defined in this table and get the report over the data quality. But how can we just manage this and improve all this pipeline and the adoption of FAIR? So in Warsica, to comply with FAIR data principles, we start to analyze the current architecture of Warsica, then implemented the required changes, so relevant data will be updated to Dataverse repository, define the data management plan, and apply the necessary metadata. Fairness check tools mentioned in previous slides provides the report for the achievements over data quality. Here we used the Fuji, Fair's Fair, and the Fair Evaluator, both being developed on this project. So going further, we are now finishing the support of Kubernetes cluster, looking forward to a configuration as code approach for the SQL as a service platform deployment. The goal is to provide the complete deployment of the platform from a Git repository. Jenkins operator is going to be adopted, providing complete automation for all SQL as a service platform components. With this approach and using job DSL, it's possible to also achieve here a serverless platform that can be used on demand, minimizing the operational costs. So let me leave you a challenge. Go and try SQA. I believe you'll enjoy it. The platform is still in development, and your feedback would be very important to improve or add additional features at this stage. In this slide, you have the links where you can get more information about the platform or get in contact with us. Anytime, feel free to contact us and follow our events in the Eos Synergy site. Thank you very much for your attention, and hope you have questions. And see you later.
Yeah, thanks, Samuel. So I will quickly check chat. Okay, I think I saw some question from Peter about fair assessment and fairness check. And Peter, is it clear enough what we are doing in this project?
I would like to hear some more technical details.
Mm-hmm. Okay, so first of all, I will try to explain why we need to do that. We have a lot of thematic services, and every service is maintained by a different country. And what we want them to use complete integration and to do fairness check of their data. So it means that if you have some service that collecting some data from some sensors, and it has a Dataverse as a metadata and data layer. So basically, we are able to test deposited datasets from this service and check according to fair assessment. And we can produce some badge that will show the fairness of specific dataset. So people will see, for example, if they're not using external control vocabularies, they will see it will be recommended to use Wikidata or NASA ontology or some other recommendations. Is it clear enough?
The purpose is fine. It was quite clear from the presentations. Mm-hmm. My interest is more about the implementation. So how do you check these things?
Okay.
And are there any fair principle where the check is not straightforward, or was it straightforward for every principle?
Mm-hmm. Okay, now I understand your question. So basically, we are using work from First Fair project, and in this project, people are building tools. So they have few tools like Fuji and Fair assessment tool, Fairware it's called. So basically, Fuji allows to do automatic assessment of fairness based on RDA metrics. And we're just basically using this information as input, and it has Swagger interface, and it's producing JSON with indication of all scores according to those metrics. I can put a link in the chat if you'd like to know more about this.
Yeah, thanks.
Great. And if other people have questions, feel free to raise your hand or add the question to the chat.
I just wanted to add about this Fuji tool. So basically, it's available for demonstration, but it works. So you can use it for Harvard Dataverse or for any kind of data repository. You can put a link, or you can put a link to OEPMH endpoint, and after you can get fair assessment. So just try it, and I'm really curious to get some feedback from you. Okay, I see next question from Ubi. Yeah, probably you can ask this question, right, Ubi?
Thank you for the great presentation, sir. I was wondering if people could say something about sustainability of the tools. What are the futures? What will it be after the completion of the projects.
Yeah, I understand what you mean. So what is going to happen to all tools after project will be finished, right? This is what you're asking.
Yes.
Yeah, it's of course it's a tough question, and we have a hope that we can build a strong community behind that will start to use it in different countries, and it should go beyond of Europe, and hopefully somewhere in Australia, Canada, United States, JEPL and SQL as a service will be also installed. And well, we also have a hope that we can get another funding to continue with Eos Synergy too. So it could be also a solution, but community is our preference. So we really want to build own community, and should be hopefully also commercial companies can join and can contribute some open source, because this library and this framework, it has a lot of potential for automation of any kind of cloud operations.
Great. So we have Phil Durbin with his hand up. Phil, do you want to ask your question?
Sure, yeah. First of all, thanks for the great presentation. And thanks for all these tools that you guys have given the Dataverse community. I always think of these as a great gift, from Slava working on all the Docker stuff, Don Sizemore, all of the Ansible and test automation tools he's created for us over the years, Oliver with his Kubernetes, Stefan, pyDataverse. So thank you for all of these tools. I had a comment and a question. My comment is that I think Slava mentioned something about Docker Hub and that IQSS is pushing images up to Docker Hub. It's true that they're under the IQSS account, but they're actually pushed by Dataverse Bot, which is a bot that Oliver created. So just so you're clear that we at IQSS are not actually maintaining those images. This is really more of an Oliver thing right now. And then my question was, and this is a question I ask from time to time with regard to DevOps stuff, is as a core developer of Dataverse, I'm often wondering like what are things that we can do to make your job at deploying Dataverse and all the tricks you want to do with Dataverse? How can we make that easier? Are there things we can do to the WAR file or to the process? I'm amazed by how much you're already able to do, given the WAR file, the software as it is, but I'm always curious if there's just little things or big things we can change to how we release the software to help you, Phil, in the sense of DevOps. Yes.
Phil, really quickly, one thing that would help from that perspective are predictable and complete artifacts with each release. I've mentioned that before, but in a given release, there may or may not be an update to the Solar schema.xml. There may or may not be an update to other files that are typically updated in some releases, but not others. And if they could be released with a version in their file name or folder name somehow.
Right. I know you opened an issue about that for the last release, so that's a good reminder. Thank you.
Phil, I can respond to your question actually. So we are moving to automation, and well, you saw we already have some progress about that. And what is really missing now, and what could be also improved, Dataverse seems to be like monolithic application that has some functionality that can be deployed somewhere outside, right? So for example, if you want to ingest tabular files, and we already faced a few situations, then old files, also SPSS files not supported by current tool. So we want just to use some external service, hopefully, deployed as serverless application somewhere and maintained by other party. And we want to get content extracted, and we want to put it back in Dataverse. And we can basically think about any kind of functionality that could be shared with other data repositories, because it seems like useful for Fedora, Zenodo, for DSpace, for other repositories, right? And we can actually think about super infrastructure that can be available for all other data repositories and could be reused by other applications. And using this approach, we using also SQA as a service, we can think about how to build this super infrastructure and how to make it sustainable. And the same, I already mentioned external control vocabulary support. So after the thought, we wanted to get this functionality integrated in Dataverse. We started to think, why not to reuse this functionality and not to make it available for other repositories as well, right? Because it's common requirement to archive concepts from metadata. So there are a lot of use cases like that, and if you think we can basically collect new requirements from community, and probably we can start to build network services that could be better suitable for the future, because you can maintain them separately, not as a part of Dataverse. And it's more, so now power is basically in the hands of IQSS, which is good. It's for sustainability of Dataverse is good. But in the future, we want to go in really distributed direction, and hopefully every organization can just focus on own stuff, own features, and develop some applications that could be shared with other communities. So just we need to think how to improve this.
Yeah, that makes sense. It's kind of like your App Store idea.
Yeah.
Philip, and if I may, I have also additional points from the experience with the users, in this case of Warseeker, that relates to the API. So the current API, it is good. It tries to expose all features, and I hope you just put your efforts on putting all the REST API as most representative of all the features you have as possible. But there is also some complaints about the web interface, about the management, the administration of the users and things like that. I have received some complaints. Well, I said that we can solve that problems using the software implementation itself. But if someone wants to enter in the Dataverse and wants to manage as directly from the web interface, we found some limitations.
Okay, yeah, thank you. Yeah, like you said, there are APIs for users, so I guess you could build your own interface on top. But yeah, I hear you. Thank you.
Yeah, I see some comments from Philip. Philip, do you want to comment on this? Philip Konzet.
Yeah, I'm not sure. I'm just pointing you to another breakout session where there will be some discussions about, integration with external services, both with controlled external vocabularies and also some preliminary ideas about metadata schema support, which we'll have on Wednesday.
Yeah, so you're more than welcome to join on Wednesday, right? Yeah. Okay, do we have more questions?
Hi, good morning.
Hi.
Yeah, so I'm new to Dataverse and this is my first session and it was really good, to give a start. So my question is, as mentioned, we can use Jenkins for continuous integration. So do we have the option to use Azure DevOps, like for the automation?
Yeah, so basically the idea that everything that we'll create will be open source, and it will be available for community. So you can reuse, you can get it installed in your place, or you can deploy in the cloud. So no problem. That's the idea.
Okay. Yeah, fine. That's clear. Thank you.
You're welcome. So do we have more questions?
Yes, we have a raised hand from Philip. Go ahead, Philip.
Yeah, I was just to come back to this sustainability issue that was raised by Ubi. So I mean, since all these tools, the quality testing tools, are developed within an Eos project, I guess this, if they turn out to be successful, they may be also be deployed by other Eos projects, I guess. So this would also provide to the sustainability. Slava and Samuel.
Yeah. So this is also correct. So we have hope that other EOS projects like EOS Pillar, for example, or EOS Hub, they can also use the same library, and this is how we can get more people from community, and we can maintain it also.
Yeah, and it could be provided as a recommended service or framework for service providers for EOS. I mean, there will be a lot of service providers because EOS is a kind of federated cloud. It's not just one service or one thing covering all the needs. So there will be a lot of different service providers, and EOS as an organization could then recommend this kind of quality testing framework as a recommendation. Yeah.
Yeah, and if you remember my slide about interoperability, so I had like 4 levels. So this is exactly the point. So we want this in EOS, and we want all EOS projects to follow the same approach and development. And I really believe that it will be successful.
And just to add that there is a big interest on Europe to adopt these tools and to implement them to achieve the FAIR principles for data and to turn everything more transparent for the scientific community.
Yeah, so if we as a Dataverse-based repository could kind of provide this integrated approach with quality testing, it would be an advantage for us if we want to contribute to the EOS as a service provider.
Yeah, and also this fairness check. And by the way, what I think Samuel also mentioned about different fair assessment tools. So now we are working on kind of common interface. So we should be able to connect other tools that will be created in different parts of the world. And hopefully they will use the same metrics, which is agreed by RDA, and they could be integrated in this infrastructure without any problems. At least this is our aim. I see Phil. Yeah, please go ahead.
Yeah, I just wanted to jump in with maybe a little more of the IQSS perspective on testing, because these presentations are fantastic, but I feel like there's a little missing piece there. I don't know that we really presented what we do. And we also use Jenkins. And I'm going to put a link in the chat now. It's jenkins.dataverse.org, but I linked to the guide where you can read about it. And so we are doing some amount of quality testing. We run unit tests and API tests. And my thought on all these great community efforts is that perhaps some of this can be merged together. So like Stefan's browser-based Selenium tests, for example, is an obvious win for me, where as a developer, I know how to write API tests and I know how to write unit tests, no problem, but I don't have the tool, or at least the habit of writing Selenium tests. So maybe if we get some synergies, we merge some of these things together so that developers like me, when we're making a pull request, I go ahead and write a Selenium test as part of the pull request. I think that would be great. And all this extra testing, fair is fair. I'm kind of new to all these concepts. I think they're all great, but I think that if we at least as a first step, maybe get some of the again, browser-based Selenium tests would be a win. That's it. Thanks.
Yeah, I completely agree, and this is why we are here, to show you what is possible in the near future, right?
Right. We appreciate that.
Yeah, we'll be more than happy to share all stuff, and it will be really fantastic to have it deployed somewhere in Harvard Cloud, and yeah.
Yeah, you have a lot to teach us for sure. So thank you.
Okay, more questions? No, Philip?
So the testing approaches you have been presenting, do they apply both for the Dataverse software, but also for the individual repositories? I guess the fair assessment is for the individual repositories, but the quality testing would be both for the software, the main distribution, but also for the individual repositories.
Oh, so I will try to explain how it works. So if you open Eos Synergy GitHub, it has a lot of repositories already. So basically, after you'll get it forked, it will go through SQA to the JEPL library, and it will start to build automatically after you will add a few files for Jenkins integration. And of course, in web interface, you can see how it's building, what are stages defined, and this kind of stuff. So it's really easy to get any tool in JEPL, and that will be used by software quality assurance as a service.
And just to add another thing, that we are also trying to automate things. So the idea is to find some kind of patterns of usability. So you don't need to care about, so you have your software, you have your own tests for the programming language that you are using. And then it automatically builds the required pipeline for your project and runs all the required tests and do all the magic stuff, and you have that information published in GitHub or GitLab or any Git platform.
Yeah. Okay. So we could run these tests on our Dataverse-based repositories. Yeah.
Yes, of course.
Okay, I think there is a time for last question. Oh, Phil, go ahead.
Yeah, me again, sorry. I had just written a note about the Clarin switchboard, find and start tools to process research data. Is that right? Is that, I guess I'm a little unclear on what that switchboard is for.
So switchboard is external application that basically was developed to connect all linguistic tools. Like if you want to extract named entities from text file stored in Dataverse, you can just start this tool. It will ingest data from your Dataverse. And after you have option to select different processing pipelines. Or you can do morphological analysis, you can do, I don't know, like statistical analysis, this kind of stuff. So switchboard is actually bridged to different virtual research environments.
And the focus is on linguistic data, is
Yes.
that right? Not astronomy or whatever.
No, just linguistic.
Okay, great, thank you.
But I think some of the tools are kind of generic tools. You could use them also in other fields, whereas some of them are more kind of domain specific for linguistic and language research.
Cool, thanks.
Okay, do we have some other questions?
All right. So if there are no other questions, we can go ahead and end the session. Just a quick thank you to our chairs and presenters. I mean, I work in this project every day, obviously, and I always come to these sessions and learn things. So it's really cool to, like Phil said, just kind of see what's going on out there. So Again, thank you to the chairs, the presenters, and thank you to the attendees who attended.